My name is Anup Singh. Welcome to my YouTube channel. In today's video, we are going to see the chapter number 1, that is Introduction for Aircraft Design. Today video, that is related to lecture 2. We already completed the half of the syllabus of chapter number 1 in lecture 1. You can find out my that video. In today video, we are going to discuss the remaining topics or remaining syllabus of chapter number 1, that is Introduction. So let's start. So first of all, I am going to again introduce what's the topics or what's the syllabus is left that we are going to discuss in today's lecture. So see here, the first topic that is related to classification of airplanes according to the configuration. So according to the configuration, we are going to see the classification of airplane. So in this case, you can see the classification of airplane based on wing configuration, based on fuselage, based on horizontal stabilizer, and based on number of engines and their location. So with the help of that, we are classified of an airplane according to the configuration. And the second topic is a factor affecting the configuration, that is aerodynamic consideration, in that case lift, drag and interference effect. Understand? And second topic, that is low structural weight, then layout peculiarity, manufacturing processes, and cost and operational economics. So this topic we are going to discuss in today's lecture, and this is the lecture number 2 of chapter number 1, that is Introduction of Aircraft Design. So guys, let's start with the first point, that is classification of airplane according to the configuration. But before that guys, again I am going to clear, the aircraft design is the purely at the starting of the chapter is theoretical, and after you can find out the numerical in chapter number 2, chapter number 3. So don't be bored, the first chapter is fully theoretical. So let's see, the first one is classification of airplane according to the configuration. So here you can find out that this classification is based on the following features of the configuration. So which following features? So here I mentioned which following features. The first one is a shape, number and position of the wing. So guys, this is a very important, and we already discussed in the classification in my short video related to classification of airplane. And then second point is related to types of the fuselage. That is also a deciding factor to classify the airplane. Then third one is location of horizontal tail, and fourth one is location and numbers of engine. So that is also important. So this 4 point is very important to classify the airplane according to the configuration. So this point is related to that. Then we are going to see the first one, in that case classification of airplane based on the wing configuration. Means wing configuration means we are seeing that wing configuration, that is shape, number and position of the wing. So that we are going to see first. So in this case we are going to see the classification. We know earlier airplanes had 2 or more wings, that is Wright brother airplane. If you search in the Google, you can find out the wing are braced with the wires, and presently you can find out only single wing is used, and this wing or this airplane are called monoplanes. Understand? When the wing is supported by the strut, the airplane is called semi-cantilever monoplane. If you see the figure number 1, so you can understand this semi-cantilever monoplane. This airplane is called semi-cantilever monoplane. Wing is supported by the strut, if you see clearly here. So this is about, but depending on the location of the wing on the fuselage, airplane is called high wing, mid wing and low wing configuration. So you can see the picture number B and C and D. that cantilever high wing monoplane, cantilever mid wing monoplane, and cantilever low wing monoplane. So this is a category of airplane, depends upon the configuration, location of the wing on the fuselage. The airplane is called high wing, mid wing and low wing configuration. And further you can find out different configuration, like if the wing has no sweep, so configuration is called straight wing monoplane. Understand, you can see the figure, this picture number is straight wing monoplane. There is no any sweep in that configuration, so that's the reason that is called straight wing monoplane. And the sweep wing and delta wing configuration you can find out in this case the sweep wing monoplane. Understand, so this is about a classification of airplane based on the wing configuration. So I hope so you guys are understand with the help of this picture and whatever I explained. So let's see the second point, that is classification of airplane based on the fuselage. So let's see how it is based on the fuselage. So based on the fuselage, if you see the picture what I have mentioned, generally airplanes have a single fuselage with wing and tail surface mounted on the fuselage. Understand, mounted on the fuselage. If you see the picture number H, that is a conventional single fuselage. Understand, the airplane have the single fuselage with wing and tail surface mounted on the fuselage. In some of the case, the fuselage in the form of pod. In such the case, the horizontal tail is placed between the two booms. Understand, if you see this figure, figure number I, pod and boom configuration. So this configuration have the horizontal tail is placed between the two boom emitted from the wing. Understand, and this airplane is generally have the two vertical tail location on the boom, and the boom provide required tail arm for the tail surfaces. Understand, and some airplane with the twin fuselage has been designed in the past. However, this configuration are not currently favored. Understand, so this is about the classification of the airplane based on the fuselage. I hope so you guys are understand. Let's see the next one, classification of airplane based on the horizontal stabilizer. So how it is based, how it is depend. So let's see in the conventional configuration. In the conventional configuration, this one, if you see in the picture, the horizontal stabilizer is located behind the wing. Understand, horizontal stabilizer is located behind the wing. In some of the airplane there is a no stabilizer and the configuration is called tailless design. If you see this one, there is no horizontal stabilizer, so it is called tailless configuration. Understand, so tailless design. In this airplane, the function of the elevator and ailerons are performed by the elevons located near the wing tip. When both elevons on left and right wings move in the same direction and they function as the elevator. Understand, when the two elevons move in the opposite direction, they function as a ailerons. And in some of the airplanes, the control in the pitch is obtained by the surface load ahead of the wing, and this configuration is called canard configuration. That I have not mentioned yet, but that is picture, but that is canard configuration of the wing. So you can find out easily if you search on Google. So this is about, guys, classification of airplane based on the horizontal stabilizer. So let's see the next one. The next one is that classification of airplane based on the numbers of the engines and their location. So this is also a very important, number of the engine and their location. Actually, airplanes with 1, 2, 3 or 4 engines have been designed, but in rare case higher number of engines are also designed. The engine when located in the fuselage could be in the nose or in the rear portion of the fuselage. When located outside the fuselage, the engine are enclosed in the nacelle. Understand, when the location of the engine outside the fuselage, the engine are enclosed in the nacelle, which could be located on the wings or on the rear fuselage. Understand, in some of the case of the airplane with the engine propeller combination, if you see in this figure, engine propeller configuration. In this case, engine propeller configuration, there are two configuration, tractor propellers and pusher propellers. Understand, tractor propeller and a pusher propeller combination. In pusher configuration, if you see this figure, and you can also find out tractor configuration. So these types of engine, you can see in pusher configuration the propeller is behind the wing, and in tractor configuration the propeller is ahead of the engine. This is a tractor configuration. Propeller is mounted ahead of the engine, but in case of pusher configuration the propeller is behind the engine. Understand, this is a pusher configuration. Understand, this is a pusher configuration, and this one is the tractor configuration. Understand, tractor. So I hope so you understand the configuration of the engine. So this is about the classification of airplane based on numbers of engine and their location. So this is very easy and simple, and is very simple to understand also. So let's see the next point, that is 1.6, factor affecting the configuration, guys. So factor affecting the configuration, which factor is affecting the configuration of the airplane? So the configurations of the airplane is finalized after giving the consideration. So which consideration and which factor? Let's see. The first factor is aerodynamics, second factor is low structural weight, third factor is layout peculiarity, fourth one is manufacturing process, fifth one is cost and operational economics, and sixth one is interaction between the various features. So guys, this is a factor affecting the configuration of the airplane. Because of aerodynamics is affecting the configuration, maybe configuration of wing, maybe configuration of fuselage, maybe configuration by the number of the engines. So aerodynamics, structural weight, layout peculiarity, maybe it's a complex layout. Then manufacturing processes, cost and operational economics. So this is a very important to understand, to find out what's the factor. So this is the factor and to affecting the configuration. Now we are going to see the next one, that is aerodynamics consideration. So guys, aerodynamic consideration, drag, lift and interference effect. So how it is affect, guys? So let's see, the aerodynamic consideration in the design process involve the following parameters. So which following parameters? Drag parameters, lift parameters and interference effects. So we are going to discuss one by one how that aerodynamic consideration in the design process and it's affecting. So the first one is drag. If you see, the drag of the entire configuration must be small as possible, and this required thin wing, slender fuselage, smooth surface condition, proper value of aspect ratio and sweep value. So if these types of parameters is possibly maintained, so drag is very low. Understand, again I am repeating, the drag is required low minimum possible as the thin wing, slender fuselage, smooth surface condition and proper value of aspect ratio and wing. Understand. If you see about the lift, so lift, the airplane must be capable to develop the sufficient lift under the various flight condition including maneuver. So in that case, the maximum lift coefficient also decide the landing speed. Understand, and this consideration required proper choice of airfoil. Understand, proper choice of airfoil and mean to prevent flow separation also, and high lift device also. So high lift device also play a very important related to the lift consideration of aerodynamic parameter. So I hope so you understand about the lift. Again I am repeating, the airplane must be able to develop the sufficient lift under the various conditions, and we are including the maneuverability also. So maximum lift coefficient also deciding the landing speed. Understand, and this consideration required proper choice for what? Proper choice of airfoil, what we are using in the wing, and mean to prevent the flow separation. Otherwise flow separation is high, so lift is low. And high lift devices is required because of to achieve the proper operation during the landing and takeoff performance. So this is about the lift. And third one is interference effect. Interference effect actually in the aerodynamics. In aerodynamics, the flow past various components like wing, fuselage and tail usually study individually. Understand? And however, in the airplane, these components are in proximity of each other, and the flow past one component affects the flow past other components, and these changes in the aerodynamic forces and moment due to the proximity are called interference effect. Understand? The changes in the aerodynamic forces and moment due to the proximity are called interference effect. And this can be, and the layout of the airplane should be such that increase in the drag and decrease in the lift due to the interference effect. That's the reason we are minimizing the interference effect. If the interference effect is high, so lift is low, it increases the drag value. Understand? And this can be achieved in the subsonic airplane by proper fillet we are using at the joint, at the wing and fuselage, tail and fuselage, and wing and engine pods. So this is a combinations. So I hope so you guys are understand about the aerodynamic consideration, and I have explained each and every parameter, lift, drag and interference effect in very detail. Understand? Let's see the next one. Sorry. Low structural weight. So guys, what is the low structural weight? So low structural weight consideration is there because the weight of the engine must be as possible or low. We require low weight. So the requirement of the thrust is also less in order to produce required lift. So the fuel consumption is less. So let's see what is required. The high strength of weight ratio material is required. Second requirement is airfoil with high thickness ratio. Third requirement is wing with a low aspect ratio, and third one is relieving load, that is wing mounted at the engine location, etc. Understand? So these types of factors is implies to use in order to minimize the weight of the airplane as low as possible. Then the airplane structure must be strong enough to take all the permissible flight load and stiff enough to avoid the instabilities like diversion, aileron reversal or flutter. That is the instability parameter. So we are choosing this parameter, but also we are considering this point that structure of the airplane must enough strong. Understand? So this is about the low structural weight and how possible we are maintain the low structural weight, that I have mentioned all the 4 points here. So let's see the next one, layout peculiarities, guys. So let's see what is that, because the name is very unique. So in this case, if you see the specific function of the airplane often designed in the shape, that is example of fuselage of cargo airplane generally has the rectangular cross section or a large cargo door, and the height of the fuselage door should be appropriate for the quick loading and unloading. That is related to layout peculiarity. That is a complex layout. Understand? So that is required to maintain and in order to get a smooth and proper functions of the aircraft. So this is about the layout peculiarity. Let's see about the manufacturing process. So guys, in manufacturing process, very important, during the detailed design, attention must be paid to the manufacturing process, because the cost of the manufacturing and quality control also very important, and we are always keeping in our mind. Otherwise, if the manufacturing cost is high, so our chances for selling of aircraft engine is very low. So we are designing the aircraft accordingly. The manufacturing cost always should be low as possible in order to get a more profit. So this is about the manufacturing process. Let's see about the cost and operational economics. In this case, cost and operational economics, very important point, that is DOC and IOC. So what is DOC and IOC? We are going to discuss here, and I mentioned here very important detail and defined content here. So that's the reason the little bit lengthy. First of all, understand DOC means direct operating cost and IOC means indirect operating cost. So let's see what I have mentioned here. The total operating cost of an airplane is the sum of the direct operating cost, that is DOC, and IOC. Understand? That is the definition of total operating cost. Total operating cost of an airplane is the sum of the DOC and IOC. That's the reason DOC and IOC is important to understand the total operating cost. So let's see that what is the DOC and how it is related and which parameter is related. So DOC is actually related cost of the hourly operation of the airplanes, like cost of the fuel, lubricant, maintenance, overhaul, replacement of the part for airplane and engine. So that is DOC is related to the cost of this parameter. But if you see the IOC is the indirect operating cost, that is related to the crew cost, insurance cost, dispenses of the airplane, ground equipment, hangar rental, landing charge and overhead. So this is related to the IOC. That's the reason that is the indirect operating cost. So I hope so you guys are understand about DOC and IOC cost. Understand? And thus for a personal plan, the lower initial cost of the airplane may be very important and more important, where for a longer range passenger and lower cost of the fuel may be the primary consideration. So in this way we are calculating the total operating cost of an airplane with the help of DOC and IOC. So this is about the DOC and IOC related to cost and operational economics. Let's see the last point, that is related to interaction of various factors. So which factor it is interact. So some of the consideration we find out that is mentioned above may lead to the conflicting requirement. For example, wing with an airfoil of relatively higher thickness ratio. If the thickness ratio is higher, so it's always creates some problem, because in that case drag is very high. Understand? That is a different interaction of the parameter. Understand? And has lower structural weight, but at the same time drag is high. So if the weight is low but at the same time drag is high because of high thickness of ratio. Understand? So it is meaningless to maintain high thickness ratio and at the same time low structural weight. We want to maintain both thickness ratio and structural weight also. Understand? At the same time, otherwise drag is high. In such situation, optimization technique is required to employed for the better compromises and better result. So guys, this is about the interaction of various factor. So guys, thank you for watching my video. I hope so you guys are understand each and every topics of chapter number 1, that is introduction of aircraft design. And here I made my all the PPTs accordingly, so students get easily understand each and every points, because theory portion is little bit high in the case of aircraft design subject. So that's the reason. So guys, I hope so you guys are understand. If you guys have any issue or question, you can ask me in comment box. And today we are completed chapter number 1, that is introduction part. In coming of the videos, the next videos is related to chapter number 2, that is weight estimation. So very soon you can find out the second video. So guys, thank you so much for watching my video.